Hello, today I am going to share with you the examples of analog input and analog output in Allen Bradley PLC ladder logics programming. So let me create a new file. Okay, you can select any file from here and then click OK. So let me create a new runs and insert necessary instructions. Alright, so maybe I insert this virtual switch, then this virtual switch here. Okay, and then maybe I will use move instruction. Okay, I will use a move instructions, and then the other one maybe I will use compare math. I will use a math instructions. So click the compute or math tab, and then I will select maybe division instructions. All right. Okay. So before I do that, maybe let me configure the I/O configuration. Okay, under the controller, you can click this I/O configuration. Just double click it. Okay, so this is slot 0, this is slot 1, this is slot 2. Okay, so maybe I want to insert a new module to slot 1. You can insert as many as you want. Okay, so I will choose this part number 1762-IF20F2 module. Okay, I will insert this by double click. So this module will be automatically included in the configuration. So this is a part number for the analog and input and analog output module. It consists of 2 channel analog input and 2 channel analog output in this one module alone. Of course, you can insert different part number for different from different module into the slot. Okay, if you want. For me, this is enough just for demonstration purpose. All right, so this one is a module card. So if you double click, it will open up the box. Okay, you can click this analog configuration. As you can see, there is 2 channel for analog input, another 2 channel for analog output. In other words, one module alone consists of 2 channel or 2 terminal points of analog input, as well as 2 channel or 2 terminal points for analog output. Okay, so channel 0 or terminal point 0 has this analog input, as well as for the channel 1. Okay, so I am going to use this analog input channel 0. Okay, so I will click this input range. You can select this 4 to 20 milliamp or 0 to 10 volt DC, depending on which type of signal you want to inject to the PLC. Because this is a simulation software, I don't have any physical PLC, so I will assume that I will supply I will supply the 4 to 20 milliamp signal to the PLC analog input module. Alright, so this data format, you can choose between this scale for PID or raw or proportional. So we will select this raw or proportional. Okay, so the output, okay, I will use a channel 0. Okay, so I want it to output 0 to 10 volt. Alright, so click OK, and then you can close it. Alright, so this source, alright, if you want to refer to the configuration, you can double click again. Okay, double click this one just for your own information. Alright, so this is analog input column slot, sorry, not slot 0, this is a slot 1. Okay, slot 1, slash bit 0 or terminal point 0, right? Then enter. Okay, this instruction will move the value from this source address to the destination address. So I will move it to my analog output. All right, column. Okay, this is slot 1, right? Slash. Okay, okay, slot 1 slash. Okay, this is a, it's not a bit is for digital, so this is a word. Okay, word or terminal point or what we call channel. So channel 0. Okay, why? You can double click here to double confirm. So the analog input channel 0 or terminal point 0, so or word 0. Why word instead of bit? Bit is for digital, word is for analog, because analog input value can be very huge, right? Analog value can be very huge, so usually in the format of word, WORD. All right, so this analog output is this one, slot 1 is this one, so I will use channel 0, so this one. So the output format is a output range is a 0 to 10 volt. The input analog input is 4 to 20 milliamp. All right, okay, and then for this division I will copy this address. Okay, 4 to 20 milliamp. Okay, if I just copy, I will divide this one by maybe I can put in the constant value too, and then I will show this in word 1. All right, this one, word 1. Okay, this is a word 1 or channel 1 or terminal point 1. This one I will use 4 to 20. All right, so this is correspond to this. The output range is 0 to 10 volt. As for this analog output, it corresponds to this channel 1. The output range is 4 to 20 milliamp. In other words, analog input for this is 4 to 20 milliamp, and the analog output for channel 0 is 0 to 10 volt. For analog output channel 1 is 4 to 20 milliamp. Alright, okay, so this I will assign the address, maybe the analog input column. Okay, by the way, this I can be analog input or digital input. The O can be digital output or analog output. Okay, so this will be slot 1, right? Slash channel. Okay, this one is a this one is a virtual switch, so it must be digital. Let me use maybe digital input column slot 0. This one slot 0 slash I will use bit 0 or terminal point 0 or channel 0. Okay, this I'll copy the address to here, and I will use bit 1 or channel 1 or terminal point 1. Okay, I will compile the file to make sure no error. So there is an error. So this address must be specified to the word level. Let me open this input file. Okay. All right. Okay. So I should use, instead of slash, I should use dot 0. Okay. So this I copy to here, and then this, oh sorry, this output, then I set the radix to decimal. Output should be this one. Okay, and then this one set to here. Okay, all right. Okay, compile one more time. to ensure no error, and then I will click here, click download, and then I will save it into the computer hard disk. Okay, I will name it maybe analog input and analog output example. Then I click here and click run to run the program. Okay, so maybe I will pull here a bit. So output I put here, the input I will put here maybe. Okay, so let's say as for this, as you know, this PLC only understand digital value or digital count. So it will not understand 4 to 20 milliamp input signal or 0 to 10 volt input signal. So whatever you want the PLC to understand, to read, you have to convert it to the corresponding digital value. In other words, you have to give the valid input data range. So for this case, the valid input data range is 0 to 32760. You can get this range from the menu, and the menu can be downloaded from Google. Okay, for example, this is an input data file range for this 1762 IF20F2. The range is a 0 to 32760. Okay, so if the source for this one, let's say is, for example, is 16380, 16380. Okay, the destination for this 16380 will move to this destination address, which is the analog output. Okay, slot 1, channel 0. This value will be moved to here. If you connect the multimeter to there, you can see the voltage is 5 volt. Why? Because this channel 1, channel 0, I use voltage range. Okay, and then this same value, okay, will be divided by 2, and then you will get half of the value of this 16380. Then it will be shown in this destination address, which is the analog output slot 1, channel 1. Okay, the signal analog output signal type is a 4 to 20 milliamp. Let me show you. Okay, let's say I trigger this virtual switch to close. Okay, what happened? It will move this output. Okay, so how about this? If I trigger this virtual switch to close, this will be reduced by half. Let me show you. 16380 divided by 2 will be 8190. So when you connect the multimeter to the analog to this module, analog input output card module, this one, and then you measure the voltage at this channel 0, you will get the voltage of about 5 volt. Yeah, 5 volt, because 16380 is the half of 32760 digital value or PLC digital input data range. So we get about 5 volt. As for this analog output, slot 1, this one slot 1, channel 1, the analog output signal type is 4 to 20 milliamp. Remember that we said just now, you can double click and see, right? This channel 1 is 4 to 20 milliamp for this one. And then the channel 0 for analog output is 0 to 10 volt, which is this one. So what happened is, if you connect the ammeter to measure the current at this analog output slot 1, channel 1, you will get about maybe about 8 milliampere, right? Let me show you. So 8190 divided by, 32760. 32760. Okay, enter time 60 plus 4. So you get about 8 milliamp. Yeah. So I hope that you understand what I'm trying to share with you. So that's it. Thanks.